the size, or if I'm not audible, please let me know through chat, or you can unmute yourself and tell me. Is it okay?
Yes, ma'am. It's audible, ma'am.
Yes, thank you.
Just a second, ma'am. Actually, the recording has not started. Just a second.
Okay, okay, sir.
Just a second. Yeah, fine, ma'am. You can start.
Okay. So I'll start with defining the problem statement of analysis of McDonald's. So you know that McDonald's, it's an American fast food company, and their motto is like I'm loving it. So it's the world's largest restaurant chain by revenue. And suppose you are a data scientist in this company. Okay. So this problem statement here will be like they want to expand their business in developing countries in the near future. So they have hired you as a data scientist. So it's your job to find out how they can expand their businesses based on cultural and economic similarities or dissimilarities. So you can find those out and you can solve their issue, and you can help them in expanding their businesses in the future. Okay. So for these, you need to get the data, do certain operations in data, which was told to you in the first class. And after that, you'll visualize the data to find out some insights about it. And then you'll do exploratory data analysis so that you can form some models which can predict something. So first, for all those things, the preliminary step will be to import some libraries, okay, for doing data analysis. So some of the libraries that we have installed earlier in the last classes were NumPy, Pandas, we have seen all those library installations. Now I'm not doing that. I'm just installing these two libraries, because here today we'll be newly installing these two libraries like data science and Pandas Profiling. So Pandas Profiling, it's a library that is used to generate basic statistics about data. So I'll show what it does in the upcoming cells actually. So these I have already installed, so I'm not running it again, but I'll just ensure that it's upgraded. So I'll just run this cell and wait till it is upgraded. So our job is to like first install these libraries and install these packages, and then install the libraries which are required. Okay, so first then in the libraries which will be required will be imported. So some many libraries you can see here, each one will be seen later. I had in my brochure I had given like matplotlib and seaborn visualizations. Here first we'll be looking visualization using these two packages, and after that in our exploratory data analysis part we'll be using plotly, because it's more it shows more interactive charts like that. Okay, so I'll run this cell also, and I have imported all the required libraries. Now data acquisition and wrangling. Okay, so I have taken two data sets of McDonald's that will be used for performing the analysis. Okay, so first one will be the menu. Okay, that means different items will be shown, and the next one will be the store information. The store information will include the information of stores across US as well as India. Okay, so for that I have already installed already uploaded these two files actually. And menu and outlets. Menu has the information about different foods that are served by the McDonald's outlet, and this outlets have the information of different stores. Okay, so these are the informations It includes category, item, serve size, all the nutritional information about the items that are served from the McDonald's outlets. And the other one, the store data set, has store ID, store name, ownership type, then street address, city, state, country, etc. Okay, these can be seen in the dataset. Okay, so if you need to look at these dataset, you just need to go to the GitHub account and you can see these datasets. Presently, I have already uh, downloaded it to my this library actually. So I have uploaded it, and from there we'll be executing this one. So I'll just run this cell. Okay, so it has a shape of 340 and 13 columns. The store location also has a shape of 340 with 18 columns. Okay. So from the data description of the two data set, one thing can be observed actually. Here item is there. Name of the item is given in the menu data set. And here best selling item, there is then again the name of the item coming up. Okay, so these two can be taken as a similar data column actually, and can be used for merging the data. Okay, so I'll merge the two data sets. One, the left one will be taken as the DF store, and the right one, store contains the outlet data and df mcd contains the menu data. Okay, and right one has the df underscore mcd, and I'll be doing an inner merge, and the left on based on the best selling item and the right one based on the column item. Okay, and I'll be dropping the labels item. So this will be stored to data. So I'll just print 3 rows of data. So you can see the store ID. The left has this outlet data set, store ID, store name, ownership type. You can see Kukatpalli, Mathapur, Banjara Hills. These are all places in Andhra Pradesh. I mean, it's Hyderabad. It's an earlier data set actually. So the state name is different. So country is there, India. So then the next thing has come up, the next data set has also come up like this: category, serve size, energy, protein, etc. up to sodium. Okay, so the two data sets are merged here. Now we have seen last class I have said that whenever you get a new data set, you first have to see what are the different samples in that. So either the sample, the head, or the tail you have to take. After that, you have to see the information about the data set and the description about the data set. So I'll just see the description at first. So from the description, you can find out different values actually. The revenue count, how much count is there. Then maximum revenue is 49.41. 50% of the stores give this revenue, fall in this revenue, and minimum is like this. Then profits, maximum profits is this much. So on an average, there is a revenue of this much. Average can be found out from here. Average is 25.67, and profit average is about 4.6. These values all are in millions. And about 25% of the items sold by McD generate a revenue about 15.19. 50% of items sold generate a revenue of about 26.6. So like that you can find out from these data. Okay, and all the things which are of numerical data types, it will be obtained from information about it will be obtained here. Now similarly, other informations can also be retrieved from the data. I have just given about revenue and profit. Other data can also be taken. Next, about the data information. So here we'll see the types of features, data types actually. So here many things are there as object. Okay, and postcode is coming as int, then phone number is coming as an object, time zone object, and the best selling item, okay, category is an object, total fat, all are coming, they are coming as float values, that's okay. Sodium is coming as an object, this can has to be changed later because it should be a numerical value. And in some cases, in some data sets, I have seen like the serve size also as coming as an object. Like serve size means how much grams are being served to you. So in some data sets, they have mistakenly given like 900 grams. G is also written if something is, if that is coming there in the data set. So here also object data type will be coming, but here in this data set it's fine. So it's coming as integer itself. Okay, so next I'll just see I'll just see 10 values, 10 rows of the new data set. Okay, just for information. So there is no null data present in our data set actually, because everything has the same value, same number of values, non-null. So then phone number is there as an object. That has come like that because phone number is coming as an object here because it's has a hyphen actually in that, and sodium feature is coming as object, it is inconsistent. So we'll do these data operations later. First we'll look at the visualization. Okay, so visualization I have done at this point because first I'm explaining about visualization using pandas, normal pandas, matplotlib, as well as seaborn. So first I'll be giving this, then we'll be going about the data cleaning, profiling, pre-profiling, post-profiling, etc. And after that we'll go for the EDA. Okay, so first data visualization, we'll be looking at this portion. So why data visualization is required? It's one of the core skills of data scientists to analyze the data. So an in-depth analysis is always required. Why visualization is required? Okay, why do you need to visualize your data? So why is it needed is that it helps humans to inspect and understand better. Okay, why is it needed? So because it's like images are processed simultaneously by our human brain, and 90% of the information which is transmitted to the brain is visual. Okay, and there is also the case of 60% of the population being visual learners compared to the other types of learning of people, like 30% only are auditory and 10% are kinesthetic. That is one reason. Then another thing is like if your images are given to your brain, the visuals are processed 60,000 times faster. Okay, text is processed sequentially by your brain, and they only remember about 20% of what they read actually. So it's important to have visualizations in your data when you present something, when you present a new idea to your stakeholders or to your peers in the places where you work, but because it's easier to understand by the people. Okay, now it will help decision makers understand how business data is being interpreted. So the advantages will be like better analysis, quick action can be taken, patterns can be analyzed, errors can be found out. So all these things, visualization is very required. So the plotting packages in Python will be like I have told you, Matplot, Seaborn, Bokeh, and Plotly. Okay, these are mainly used. So since I have installed it earlier, I'm not executing this line now. And so intro to visualization using Matplotlib. Matplotlib is a plotting library for Python programming language, and it has different PyPlot. It uses PyPlot interfaces used by us to plot interactive graphs for data analysis. and it has certain functions. You can read through this later. Then intro to visualization using pandas. Pandas also have many software libraries written. It's a software package written for data manipulation mostly, but it has some things for analysis also. Then it is used for plotting interactive visualization because it's built on top of NumPy and Matplotlib. And then the plot method on series and data frame is just a simple wrapper around plot. Okay. And to get more information about it, you can see there. And visualization using Seaborn. Seaborn is a Python data visualization library based on Matplotlib. And here also high-level interface is provided for drawing attractive and informative statistical graphs. So the first portion, we'll be using all these three packages to see how the data can be visualized. So we'll move on to all the different types of plottings that is present. Okay, so the types which are known as univariate, bivariate, and multivariate. Okay, so univariate means it depends on a single characteristics or attribute. Bivariate means there might be two characteristics on which we'll use to describe a type of data. Then multivariate plotting means there are two or more characteristics or attributes which are required to do the analysis. So first we look at univariate plotting. And in univariate plotting, these are the different types like bar chart, line chart, area chart, histogram, and donut chart. Okay. And at the bottom, the syntaxes for each of the different charts are given. So df.plot.bar will plot a bar chart. So inside these syntaxes, many different um, parameters might come, many different functions will come, which will change or customize your graphs that we'll see in each of the cases. So if you want an area plot, you can just type plot.area, then histogram plot.hist. And for a donut chart or pie chart is the basic of a donut chart. The inside circle is removed and you'll get this donut. Okay, of a pie chart, if it's removed, you'll get a donut chart. So it's a variation of a pie chart itself. So first we look at the bar chart. So for creating bar chart, I'll just take the menu dataset df_mcd, that is the menu dataset of McDonald's, and I'll take the category of the foods actually, and in that I'll take the values of the category, take the different values that are present in values means the names of that categories. Okay, names we can call that labels, and in the other one, the values, the total count of each of the menu items present in that category will be given as the Y value. So I'll just run this and you can see what happens. So the different labels, hot beverages, breakfast, cold beverages, smoothies and shakes, chicken and fish, all these things are the labels of food which are served by McDonald's. And the number of foods, number of items that are present, or you can say the frequency of these specific foods in the data set are given below. That is the y-axis values. So we want to construct a bar chart based on the labels as well as the times they are appearing in the data set. Okay, I mean how many times they have been ordered by the customers. So I'll first create a custom figure size using this command plot.figure. Figure size is equal to like that I'll specify, and after that I'll just give plot.bar. This color can be specified. If you want to change the color, maybe the normal colors like blue, yellow, all those things are given like in that names itself. If you want to look for more colors, you can just type like pandas plot to bar and color codes like that. You can type and see. Okay, so you'll get more many of these data, and yes, you can go at this link which is given here also for finding that one. Then this particular line is for changing how the x-axis appears actually. So here you can give x ticks, here you can give like it'll be repeating in all of the other charts also. So here you can give like if you give ticks equal to some value, then you can arrange how your x-axis divisions will appear. Now rotation I have given as 90. That means the labels will be rotated in by 90 degrees and you can display it, and it will be displayed like that. The size of the labels will be specified as 12. So then the y ticks is that y-axis values I have given a range from 0 to 100 with a variation with a division of 10 in between. And I have the step size is actually 10, and size of the labels size of the values I have given as 12. Then x label I have given as a category, size is specified there for that one also. Y label as number of items, and the title of the graph I'm giving as number of items per category, and I have to display the output using plot.show. Okay, so the commands from these up to these, okay, this will be repeated in almost every graph because these are similar in almost every type of the plot that we'll be doing. Only the things will be changing, like this command will be changing. Okay, so I'll run the specific cell, and from the graph it can be observed that this hot beverages, okay, hot beverages has the highest number, about 99 we had seen when we had run the number. Okay, so hot beverages has the most number, it's the highest selling category amongst the other categories. From this graph you can see immediately see that chicken wings is the lowest selling category, okay, based on that data set. Okay, and these are the other things which are sold by Menti. Next is line chart. Line chart is a series of data points with a continuous line. It is good for depicting trend for different categories over a period of time. Okay, the bar chart we used for seeing how many items are there, which have been sold in the different categories. Now, line chart will be used for seeing different trends. Okay, so trend is like what we can see is like we can see the energy of the different things actually. So in the different items how the energy is varying for the different items. So for this one I have just given this a value like this. This is have given because I have just seen the maximum value from the describe function. Okay, I'll just show you how to manually inspect that. Like you just see here the energy is like maximum value is that 1880, and then the minimum value is 0 only. So the mean value is 334 coming. Okay, so based on that we can also specify the range, or we can find out at the same time itself we can find out what the maximum value is. Okay, so I have for this one, for this line chart I have given the y-axis range up to 350 because we have seen like 347 items are there in the data set, and I have given 2000 as this higher value because we have seen the maximum value as 1880. So I'll run this cell, we'll see what happens. So this is the variation of energy across different items. Okay, so I haven't given the name of the items there. We are just seeing one item. No, it's univariate plotting. So we are just seeing how the variation happens. So here the index number is the list in which the item appears in the data set. Okay, so here you can see that in this portion between 160 and 170 you are having the higher energy item. Okay, so I'm just putting like dfmcd, that is our data set, data frame actually, and I'm just seeing what all foods are appearing in that range. Okay, so just to get an idea of which food has the highest energy. Okay, so we are getting like in that region salads are there as well as chicken and fish are there. Okay, so maybe we can say that in this region maybe chicken and fish has highest energy. We have to see other data also, but since salads are less in protein and fats compared to this say, chicken and fish, maybe we can tell that the amount of calories present more present in chicken and fish. Okay, so only 4 items are there, but that 4 items are contributing to the increase in energy in that indexes. Okay, then area chart. Next one is the area chart actually. Area chart are line chart but with the area under the shaded line. So for that, I told you, no, we can just see the describe function for seeing what is appearing in the what can be given in the ticks of the x-axis as well as y-axis. But you can also see it like this, like df underscore mcd total fat. You can see the max values, and in that max value you will get what is the maximum value of total fat in your data set. So maximum value is coming as 118. Okay, so I have just given like I have given a range up to 130, and the items I have given up to 350. So here for plotting area charts you have to give plot dot area, and I'll just run this one. All the other things are similar as earlier. So this is the area chart. So similar graph is coming as the line chart. Okay, and here also between 160 and 170 there is a huge rise or a peak is coming. Okay, so similarly I've just given this as an index as 150 to 170. So here about this much chicken and fish items are coming. Okay, so they might be contributing for the rise in total fat. Okay, now histogram plots. Histogram plot is a graphical display of data using bars of different heights where each bar group numbers into the ranges. So for histogram plots you can see, just go to the pandas data frame dot histogram. All these links are given in the notebook. You can go and explore it later. So first for that I'll just see the information of the data set once again, and I can see all these things here. So what I'll be doing is that I'll be taking the serve size. Okay, and I'll be creating custom bins for the graph because histogram is like it's a um, some different bins are present there, means some ranges are present there. So you have to give these ranges to the x-axis, and for that purpose I have created these different custom bins with these values. So I'll give plot.hist bins equal to these different given values. I have specified a color, and I'll be plotting this surf size, and the rest of the things are similar as earlier. Okay, so if I run this specific cell I'll be getting the histogram plot. Okay, so histogram, these are the range of values in the x-axis, and this is the frequency in which the surf sizes are varying. Okay. Now this KDE plot is the next one. It helps in visualizing distribution of data over a continuous interval or time period. So it's a variation of a histogram, and for KDE plot documentation you can see that in the link given. So here also plot.kde, that is the function to be used, generate kernel density estimate using Gaussian kernels. So we'll be checking the surf size itself in this one. So I'll just run this cell. So this is the k density plot. Okay. Then this will show the density. The peaks of density plot help display where the values are concentrated over an interval. Okay, so data in surf size column is somewhat following a normal distribution. Somewhat following, not correctly. And then the difference between a bar plot and a histogram will be like histogram will represent a range of values, whereas the bar plot will represent a single value. Then we are breaking up the histograms into okay, this thing comes because I haven't been using it for some time. So okay, so then the histogram breaks space up into even intervals, so they don't deal very well with the skewed data. Okay. Now, next one the last one in the univariate plotting will be the donut chart. Okay, so donut chart, it's a variation of a pie chart that is hollow in the center, so it makes it look like a donut. Okay, so pie chart usually are sometimes criticized for focusing readings on the proportional areas of slices to one another. So for that, donut chart is means remedies that problem. Okay, by de-emphasizing the use of area. So since that shortcoming is there in pie chart, people have moved on to donut charts. Okay, in this donut charts, that pie plot documentation is there. So I'll just run this one here, and plot. This is the command for that one. Plot kind equal to pi, and if we run this one, we'll get a donut chart. Okay, so this legend show the hot beverages. It has about 29%, and then breakfast takes up about 14.4%. Okay, so this is the donut chart, and we can observe the share of each category value in the data. Larger strips of donut represent higher share of a particular category. Then next one is bivariate plotting. Bivariate plotting contains these many charts: scatter plot, hex plot, stacked bar chart, bivariate line chart, and pair plot. So these are the different commands that can be used. Okay, and one of these things has the seaborn plot actually. So first we'll move on to scatter plots. Scatter plots include this command actually, plot.scatter, and here, as the case with bivariate plotting, x is equal to carbohydrates. We are comparing with two different columns, carbohydrates column and energy column, and we are giving the figure size as 15 and 7. Okay, the rest of these portion is similar in every case, so I'm just running it. So this is the scatter plot. So there is one problem here in the y-axis. The values are very closely spaced together. So maybe we can change the step size, increase the step size maybe, or We can try also decreasing the size. We just see how it comes. Okay, this is now more evenly spaced now. So that is all right. So from here, you can see a scatter of plots here. Okay, it's very distributed very randomly, but you can't see a trend here. Okay, somewhat trend can be observed, but it's not very clear. Okay, and one thing you can say, like the variation of energy increases with increase in carbohydrates, but it's not impactful. That visual is not very impactful. So if you need to see impact with your plot, you can see a regression plot actually. Okay, regression plot will plot a similar graph itself, but the thing is that you'll get a visual guide that help to emphasize the patterns in the dataset, and usually it's used to help visualize linear relationship. It creates a regression line between two parameters. Okay, this is a seaborn plot actually. So SNS dot regression plot. The values are between carbohydrates as well as energy. So if you run this cell, you can find that a similar plot is coming. Okay, I'll change here this also. I'll change to 100. I'll run it again. So here you can see that similar scatter plot is obtained, and with that we are getting a regression line also. Okay, so this regression line will show that there is a positive correlation of variation of energy with respect to carbohydrates. Okay, and as the carbohydrate present in an item increases, there will be an increase in the energy value. So this much we uh, can be inferred from these two column datas. Okay, then shortcoming about this data about this plot is that it doesn't care about the density mapping of points at the same place. Okay, so we can know that whenever there is an increase in carbohydrates, there is an increase in energy, but we don't know how many items are there in that particular point. Okay, for example, let's say that there are 2 points that have the same value of carbohydrate and energy, like 30 carbohydrate value and 50 calorie value, energy value. So, but we don't know how many from a scatter plot or from a regression plot, we can't know how many items are there with these same values. Okay, to solve that problem, a hex plot is taken. Okay, hex plot, it aggregates points in space into hexagon and then colorize those hexagon. Okay, so if you see a darkened color of those hexagon, the color scale will be given at the sides, and according to that you can see how many different items are present with the same values of carbohydrates as well as energy. So in this case I have taken surf size and energy. Okay, so surf size it's similar, so it's another column. So depending on the surf size, how energy varies, we'll see, and how many are there with the same value. So I'll just run it. Before that, this is the um, command which is to be used, like df underscore mcd dot plot dot hexpin. X-axis value you're giving as surf size and y-axis as the energy. Color you have to define, figure size, grid size, all those things you have to define. So this is the energy versus the surf size. Okay, so energy and surf size, and this is the number. So a higher green value will show that this particular value 150 400, that value will be more times, about 14 items are having those same values. Okay, the top one will be showing like a slightly lesser green intensities there, so we can take it value as 12, and about surf size 150 and energy 450, about 12 items are there. Okay, so you can see maximum density of points lie in the surf size range of about 150 and energy of 400. Okay, next is a stacked bar chart. So the stacked bar chart is one in which plots the variables on top of the another. Okay, so we'll just see two variations. The second variable in a stacked plot must be a variable with limited number of possible values. These are one of the limitations. And there is another limitation, like if the contrasting colors aren't used properly, there will be a difficulty in interpretation. Okay. So in this, we'll be using the group by function that we learned last class. So group by will be used to group category as well as one other column. Okay. And this will be using for stacking. So how much stacking is required, we'll be giving line by line. Okay. So if I execute this one, the rest of the things are similar. You can go through them. So if I execute this one, you can see that total fat, saturated fat, and trans fat. These are the different categories given in terms of fat. These are the different fat columns which are present in that data set. Okay. And for each of the different items, you can see how it is distributed, how the fat content is distributed. Okay. Now, if I am means this is the stacked version. If I am just commenting these lines and I am giving a group by for category and I am giving all these together and I'm plotting them similar, and color variation also I have given together. So if I am running it instead of the earlier one, then you can see here that everything is present there, but it's not coming as a stacked plot. Okay. So if you see this one, every variation is coming. Total fat, saturated fat, trans fat is coming, and the categories are also coming, but it's not stacked on top of each other. Okay. So if you need stacked one, you have to give it separately. Okay. Next is like um, we can just see how the customers and vary with the revenue. Okay, I'll just run this one. This is similarly. This is like a area plot, variation of an area plot, but the thing is that this is also a stacked area plot. It's a variation to the stacked bar plot. We have seen bar plot as well as area plot earlier. So this is a variation to the area plot. Here also I am using a group by and I am stacking the areas. Okay. So you can see that this is the revenue as well as profit. It's kind of indecipherable with this thing. You can just see that the revenue and profit will increase with the increase in number of customers. Okay. Just it's not very decipherable from those graphs. Okay. So it can't be used in this scenario. I'm just showing it to show how this graphs will behave. Okay, this particular graph can't be used for analyzing this data set. Next is bivariate line chart. So line chart, we'll take these values actually to see the relationship between them. That means I'm taking serve size as well as cholesterol and serve size as well as total fat. So if we use stacked line plot actually, this is stacked line plot. So if I run this one, you can see that this is varying like this. So for different serve sizes, the amount of total fat in grams and cholesterol in milligrams follows a similar trend. Okay, you can see these lines following a similar trend. Yes. So amount of total fat increases, the amount of cholesterol also increases with it for each serve size. Yes. And still, so we have plotted the different variables, but still we are able to see the trend. They all follow clearly. So for serve size and the cholesterol and total fat values, for seeing their relationship, the stacked line charts will be useful. Next will be a pair plot. Okay, pair plot is used to plot pairwise relationship in the data set that we use. So the diagonal values will show plots relationship to of each variable to itself. And for more documentation or for more information, you can see the Seaborn documentation of pair plots. So I'll come back to our program. So this one I have given like some features I'm extracting from the tf.mcd, giving it as a subset. So energy, total fat, sugar, carbohydrates, and protein. And I'm using the Seaborn SNS library for plotting the pair plot. Okay, all the things I have given, and the diagonal I am plotting a k density, which we have seen earlier, k density plot. So the diagonal elements will be having a density plots. These are the diagonal. That means energy plotted with energy. Okay. Just for more clarification, I'll show it in the new figure. So energy with energy, this the diagonal elements will be plotted with each other. And from here you can see that energy with total fat. Okay, this energy, that is this one. Okay, this one has a positive correlation and has most of the data falling in between or near a positive regression line. Okay, so this has a very good positive correlation compared to all those other things. Okay, so I'll come back here. So high positive correlation can be seen between energy and total fat columns. Diagonal element shows the frequency distribution of that particular column. Okay, it is plotted as a KDE plot. Next, we'll be moving on to the multivariate plotting. So in multivariate plotting, the different types are a scatter plot, box plot, heat map, parallel coordinates, and swarm plot. Okay, so in these multivariate scatter plot, so multivariate, many different variables are there. He'll be using three variables. Okay, so x is sugars, y is energy, and the hue will be given as category. Okay, so the color variation will come for the different categories. Okay, this is the SNS dot scatter plot. So I'll just, the data is given. This is the syntax for the plotting scatter plot. You can see the syntaxes in the documentation. The documentation has for each and every documentation, you will be having examples also. From that examples, you can see what is the syntax for each of the things. So data is given as here tips. Okay, so likewise you can formulate your problem, and according to your problem you can change the values. Okay, it's simple, it's very simple for taking these syntaxes. So then I'm creating a scatter plot. I'm giving these labels, and I'll just run this one off. So from this, the observation, I'll show the observation. If you can see, salads are there at the bottom, and chicken and fish have this one. So this color, okay, I think this color is similar to the topmost present there. So this particular thing is given by chicken and fish. Okay, so chicken and fish has the least amount of sugar, but with that least amount of sugar, it's giving the highest energy because it's mainly made up of protein and fat. Okay, so the food which has very less sugar, but still it gives very high energy, is chicken and fish. Okay, salads are in that region. The sugar content in them is less, as well as the energy content is also less in salads. Okay, so from these you can see how many are there. So this one, around this area, the cold beverage or smoothie area, it has higher energy, but it has high amount of sugar content also. So from this you can see energy variation with sugars per category. Three variables are here now. Sugars are there, energy is there, and the category value. So it's a multivariate plot. Next one is a grouped box plot. So box plot or a whisker plot, it's also known as a whisker plot. It is used for displaying the data distribution through their quartiles. So for the data description, we have seen the 25th, 50th, and 75th quartile. So all these quartiles can be seen in the box plot. Okay. Then the lines extending parallel from the boxes will be known as whiskers. So I'll just run these. The variables I'll be taking will be state. So this one will be from the data of this stores. The MACD stores are stored in df underscore store. So that data will be taken, and from there the columns of state, revenue, as well as the palette will be given as a rainbow palette. Okay. So in that we'll see how it's varying. So the third variable will be like the frequency. Okay, the revenue will be there. The number of data which is lying there, that will be shown by the third. The third variable will be that. The first variable will be state, second will be revenue, and how many stores are lying in that revenue range will be shown by the box plot. So the for these lines, the end lines are known as the whiskers, and outside the whiskers, if some points are coming, they are known as the outliers in your data. Okay, so these are some of the outliers. In most of the data sets, it's preferable to remove these outliers before you do some analysis in your data. But there are some cases in which there will be outliers, but you can't avoid them. Okay, so in most of the cases, outliers might be coming up. You have to analyze then why the outliers are coming up. Okay, if you are seeing that the outliers are coming up because of some reason, like some mistake in your data, then you have to remove it. But if the outliers has come normally, then you have to keep it. Okay, so here up to this one, actually up to MH, these are the Indian states: Andhra Pradesh, Delhi, Haryana, Karnataka, and Maharashtra. The other states are from US actually. Okay, so then this is not Tamil Nadu. Okay, so this one is Indian states revenue, and these bigger ones are shown by this revenue of the US states. Okay, so here from in the Indian states, the top whisker is shown by Maharashtra, and also the 25 percentage of stores in Maharashtra are having higher revenue compared to Karnataka as well as Delhi, as well as it goes way high above the Andhra Pradesh range. Okay, so you can kind of say that most of the stores there in Maharashtra has higher revenue compared to others. Okay, so some things you can draw out from these states, and from the US dataset also some similar things are coming up, but highest revenue, most of the things, okay, that we'll see in later plots also. But just for observation, this particular blue line, this box plot, has their 25th line, 25th percentage, way higher than many of the states in USA also. Okay, and its topmost store, okay, 50 the 75 percentile also has coming up above the other states. So it's the okay refers to Oklahoma. So this is in the case of the different states in US. Okay, so this is the observation obtained from this box plot. So it's difficult to squeeze enough dimensions onto a plot without hurting its interpretability. So next type we'll be looking at is heat map. Heat map is a technique that shows magnitude of a phenomenon as a color in 2 dimensions. The variation in color may be by hue or intensity. Then the individual rows or columns are divided into subcategories. Okay, so for creating a heat map, this is the command use sns.heatmap, and the data I'm giving like the menu data like df.m underscore mcd, and I'm using this function correlation. Okay, so when I run this specific cell, you can see that the correlation of features, okay, the different features are there present. and serve size, with serve size we'll obtain this one. Okay, means this is the diagonal lines. It will be having the data of same items. So if you want to see the most highest correlation, excluding the relation with each other, we can see that around there is a value around 0.91. Okay, that is the relation between total fat and energy. Okay, so this has a very high positive correlation, and there are negative correlation values also. There is a negative 0.29, that is fiber and sugars have very negative correlation. I mean, that means if sugar content increases, there is less possibility of fiber content in that. Okay, likewise we can see the relation between these all these variables. Okay, now value close to -1 gives a strong negative correlation, +1 gives a strong positive correlation, and 0 refers to a weak correlation. Okay, next is a parallel coordinates type. It's used for plotting multivariate numerical data. It's used for comparing many variables together and understanding the relationship between them. I'm just showing this here. It's not much useful in this particular data, but you can see how it is there. Actually, also I've just taken these features, category, item, sodium and sugars, and then I am getting the min max scaling for those columns. Then I am plotting. I have just given the info and describe to see what the data set is. I'm not running that one now. So I also defined sugar levels, that is just for comparing. Okay, so I'll just run this one. You can see how the variation, how the line varies for energy, protein, total fat and carbohydrates, and these are the different menus. So since this much features are there, I'll just change this one with um, I'll change the class column from category to sugars, because I have given a particular division like sugars. If less than this value, this is the normalized value that is obtained. You can see it from the describe. So you can see that the sugars have um, okay, this is not correctly now there, so I have to run this again. mm, okay, it had very, so okay, I'll come to that later. So if you have to change this one, I have to run these things again, so later I'll be running it again. So we'll go to the next one. Actually, violin plot. Violin plot is similar to the box plot itself. So in box plot, um, you can see the variation like this one. Okay, it's varying like this. So for violin plot, you will get a similar thing, but here it won't be visible right now because so many parameters are present here. Like I have given like category I have given. Okay, so energy variation of that category. So you can see many things there, but presently since many categories are there, it's not very observable. Okay, this is similar. A blocks plot is there in between. Okay, you can see more information about the violin plot in Seaborn using this thing. Okay, in violin plot, this is the usual violin plot that is obtained. Inside it contains a box plot inside. Okay, so it's like it's a similar role as a box and a whisker plot. It shows the distribution of quantitative data across several levels of one or more categorical variables so that those distributions can be compared. Okay, so you can create those plots where the number of categories are less. So you can have a bigger figure size and you can see it clearly. Okay. So these are the different visualizations that are present in the data. Next, we'll move on to the exploratory data part. So first, we'll have to do the data pre-profiling. So I'll just see the pre-profiling report. So in the pre-profiling report, it's making the data set, and just wait for some time. So it's used for getting a quick analysis of Pandas profiling. From there, I have got like there are about 30 features, of which 10 are categorical, 18 are numerical, and 2 unsupported type. And many, I'll show how the Pandas profiling report looks like. So if this particular report is formed, you don't have to do any other data analysis operation to that. You might have to do some manipulations like some data cleaning, some other data operations need to be required, but here you can just see how the profiling can help you in analyzing your data. Okay, so it's just running. Now the file is formed, and I'll just open it when it comes. Okay, so it's downloading. So after that, we'll be seeing it right now. After that, we'll be looking at how to drop certain unnecessary features. Okay, so that is from the profiling actually. So this profiling, it's getting downloaded. Please wait for that. Yes, so this is the profiling, Pandas profiling report. There are 30 number of variables. Okay, this is the profiling report. They'll give you certain overview, alerts, and reproduction. Then, so about how many number of variables, how many observation, how many missing cells are there, how many duplicate rows. For before these, you will have to do each and every function you have to write for finding the number of missing cells, number of duplicate rows, which I've shown in the data manipulation part. So you don't have to do any of those things now. You just have to run this profiling report. Okay. So this will show all the variables like store ID. It has high cardinality. I mean, high number of unique values are there. Then store name, ownership type, all those things will be given. Okay, about all the variables will be given. It's loading only. Energy, all those things will be there. So from these, you can find out what all changes you need to do in your data. Okay, so next one, we'll move on to some operations in our data like cleaning. Okay, we don't need the postcode, phone number, and time zone. That can be dropped. And also the number of employees are not as the number of employees are coming as I'll just show you that the number of employees are coming as a float value actually. Okay, so that float value can be removed, and what you can do is that I'll just run this one, and this profiling report, it's taking time. So postcode, time zone, latitude, revenue, profits, number of employees. Okay, so number of employees, I'll just toggle the details. I hope you can see this one. The maximum value, okay, it's coming as 148.33 minimum value. I mean, float values are coming. You can't give like the number of values as float values, right? So in such a case, we have to floor that data, okay, and make it as an integer data. And similarly for customers also, we have to make it as an integer data. That's why these operations are done. Next, serve size. Um, we'll just check some see some data which if it needs to be cleaned or what. So we have taken some values from surf size and some values from sodium levels. So in sodium levels you can see that there is a hyphen value. Okay, so these hyphen values can be changed with the replacing it with the median. So the top one I have given like replacing G with a space. So this is for if in case your data contains the gram value. Okay, so this also can be run and you can see the results. Okay, so after doing these things, a post profiling report can be done. That also I'll run, let it be there in the background. So post profiling will show whatever changes you have done to your data and if you have got rid of the many unsupported data type features. Okay. Now, exploratory data analysis. Okay, so exploratory data analysis will analyze the data set to summarize their main characteristic. It is to primary goal is to retrieve a maximum amount of information from the data set. So it will give all these information. So for this subsection, I'll be using the library known as Plotly. So Plotly, more information about Plotly can be obtained from that link. You can go through it later. So I hope my screen is visible. Then, so first, some analysis I'll be doing, like outlet matrix based analysis. I am just asking this question. I want to see how many stores are owned and run by McDonald's. Okay, so I want to see the ownership type. So I'll give in the labels like index and values like this. So go.figure, this is the Plotly initiating, and if I give trace equal to go.py, it's the pie plot in the plotly. Okay, so difference from this pie plot with the other pie can be seen here. Okay, this kind of look like Donald chart itself. Here you can see that 39 point. It's an interactive type of graph. You can see that company owned number 132 numbers are there with the variation 39.5. Joint venture is there 82 and licensed is there 120. Okay, so about this much can be done. Then I want to see which top outlets generate maximum revenue for the country. So I'll just see that, get the value of top 10 outlets. Okay, so just taking the revenue and sorting values. Ascending I'm giving as false since I want to get descending values. So I'm getting 10 values and from there I'm just seeing two of them. Okay, so you can see the store names. Most of them are located in US and that itself Oklahoma and Ohio. So from there you can get this, use this particular figure. Okay, scatter geo. That will create a geographical plot, geographical scatter plot. And here you have to give the longitude, latitude, store name, revenue, etc. Okay, so means the latitude, longitude will be like that. So you can see that this plot can be zoomed in, it can be panned. You can see the size of the highlighted portion. Okay, the size of the markers will give the revenue amount actually. How much revenue is, means how high is the revenue, the dots will also be bigger. So if placing on top of that, you can see the latitude as well as longitude. You can see the name of that store. Okay, where it is. Yes, all these things can be seen from the Plotly geo scatter plot. Okay, now I want to see which top 10 outlets create maximum profit for the company. Okay, that is similar. And if I do a geoscatter plot of that one, I can see this is the variation. Okay, these are the plots. Now these are drawing like exploratory data analysis is like drawing some questions from them. Okay, seeing some questions like I'll move on to the Indian scenario actually. So before that, I'll just look at the nutritional value based analysis. Okay, so I'm just giving like different category, and I want to see frequency distribution of the menus. Okay, so frequency and the different menus. Okay, so you can see that hot beverages are dominating. And then if I want to see how on average how many calories are present in each category of the menu, I just have to see a group by of category with energy, and just I am plotting with a plotly bar plot. Okay, the difference in plotly bar plot is like you can see the values as well as the names. Correct values can be seen. Okay, next one, I'll be moving on to where you can see which sort of foods and beverages to manufacture include fiber. So if you want to see that, you can see a box plot here. This is a plotly box plot. Everything is written there. The quartile 1, median, quartile 3, and how many numbers are there in that one. Then all the values which are present will be specified there. Okay, so from there you can see that salads have a higher amount of foods with higher fiber content, so they have high fiber content as compared to other items, but only few different items in the salad category. Now, next, these all things you can run later. Then geographical information based analysis. So we want to see which top 10 cities have the highest number per capita. Okay, so if I run that, you can see that highest outlets. Okay, Mumbai, Delhi, Bangalore, all those things are coming with some cities in US also. Okay, now I want to see a different plot, like what are the outlet locations in India and US. So I want to see the scope of both the areas. Okay, so a world plot is taken. Okay, so in that I'll give like this scope is like world. Earlier I had given as US. Now the scope is given as world, and these all things can be taken. If white is changed as blue, for visualization change only, you can see the coastlines changed as blue. Okay, many different changes can be done. Now, outlet metrics based and nutritional value based analysis, some things we'll see. So, which outlets have most nutritious item as their best selling items? Meaning, which outlets are there selling most nutritious items? So, nutritious item I have earlier explained as the things having protein, etc. All those things as nutritious. So that has to be run in for this one. So in that, I'll just have to run this one. Yes, and from that we'll come to the nutrition based thing. Okay, so if I run this one, you can see that concerning the nutritional item, this one, Houston, this particular thing has a higher data. Okay, higher nutritional containing outlet. Okay, the marker size will give the nutritional content of the best selling item of that particular outlet. Okay, now what is the revenue of the outlet based on the category of the best selling item? So if we run that one, salads. Okay, so from this you can say that salads is best-selling item have lower frequency but higher revenue as compared to other categories. This may be because people have become health conscious and only try to eat healthy food. That's why maybe some revenue increases there. Now, outlet metrics based and geographical information based analysis. So where did McDonald's enter into joint venture? That we have to see in India as well as US. Okay, so these values I have extracted and I am plotting a bar plot for both the countries. So the syntaxes you can check earlier. So you can see that in USA I have given in red and blue I have given in India. So the red, you can see that in USA the types of stores are either company owned or licensed only. But here in India it's coming as joint venture companies. Okay, so You can see that McDonald's has joint venture with other companies in major Asian economics lives in like India. So if you see the McDonald's information, actually, McDonald's India information, McDonald's India. So you can see joint venture report. Okay, McDonald's joint venture in India. You can see that they have their own data actually. You can read through this later. So how they are maintaining joint ventures in India. Okay, this is a locally owned company by two Indians. It's managed by two Indians here for North and East India. One person is there, Vikram Bakshis, and for West and South India, Amit Jatia. Okay, so you can view that. That is given here also. Then what are the 10 outlets in India and US based on revenue? If you want to see that, you can just visualize it here. So based on revenue, okay, the higher thing is seen in the US area itself, okay, because revenue is more compared to India. We have seen it earlier also. So the size of this dots will indicate the revenue. In India, this size is very less actually. So revenue is less compared to the US case. Okay. Next, what is the average revenue of outlets in each US state? That can be seen. So that is will be USA plot only. Okay. And many other things can. Next metric will be nutritional value based and geographical information based analysis. So I have given different nutrition factors and I am seeing for the different countries. Okay, so here in India and US, how the different things, categorical nutritional difference in India. So it's evident that US is rich in nutritional content. Foods provided in US, maybe because of the use of genetically modified food crop, but it is not advisable to have those things because it is supposed to cause cancer, and so people are moving on to organic foods itself. So but still the amount or product will be more if you are using these type of things. So that might be the reason why the nutritional content was higher there, because the produce obtained there is usually genetically modified. Now, how the Indian menu items compare to US menu items in terms of nutrition. Okay, so nutritional factors I've just given. This is like you have seen, you can see in, with respect to sugars, you can see with respect to fats. The variation I have done is like um, it's a box plot itself with energy asset first data and countries a variation. Then I'm adding a button there. This button includes all the other factors. Nutri factors means all the other listed factors here. I have given a list of all these other factors in Nutri factors. So I gave this as a button. So you can see the variation of these different features, countries with all these features. Okay. Now you can draw other things like outlet metric based, menu items, and geographical information based analysis. If you do that, you can see in US salads, figure in the figure I have given category, country and category as one group, and with revenue variation with revenue. So you can see how the revenue varies with country as well as the item. Okay, so in India and cold beverages has this color. Okay, so higher proportion is taken by most of the US items in US actually. This is was the Indian items. Okay, So we'll look at the summarization of the different data. That means from you can go through the different analysis that were done earlier. So the summary will be coming as items in the menu data type can be categorized as nutritious food and non-nutritious food based on different chart diagrams. So it's beneficial for demonstrating different range of values for food nutrients like protein, sugar, dietary fibers, fat, carbohydrates, cholesterol, and sodium. And you can see that the Indian US food industry has risen as a high development and high benefit area. So India is still lacking in its initial steps and could be the reason why India is not being profitable after many years of operation. So these are the conclusions that are drawn from the data which is given. So some actionable insights that you can do is that in order to increase the outlet metrics like revenue, profits in the Indian outlet, they need to open new outlets belonging to company owned or licensed ownership instead of joint ventures. That is one of the steps that can be taken. Now, next is like the food nutritional content can be improved by using good agricultural practices that will be taken up in India after carrying out, but it should be after carrying out proper analysis and study because you can't just simply introduce genetically modified crops or high yield variety seeds into the system because nowadays studies have come up like use of these will cause some different problems in humans. So the use of these for increasing the nutritional content and as well as the produce should be taken after serious study only. Okay. Now, McDonald's India, they need to introduce more food items in the menu because here, usually we'll see fat containing items only here, and salads and all are very rarely seen in many of the outlets. So, they need to introduce more food items on the menu. So, these are the actionable insights which can be seen from this data set. Okay. So I hope we have gone through the data visualization part as well as the data exploratory data analysis part. So I have used this specific data set. Okay, if required, I can send you other data sets also, which can be used for studying about these things. So each and every data set that you get, when you if you have to do machine learning or deep learning operations, the preliminary step is like to understand how your data behaves, to draw out visualization from that, and to get insight about how your data is behaving. So this behavior will help you in forming models and will help you in seeing which all factors or features you can take for designing your different algorithms. So I hope this course has helped you to do that. Thank you.
Thank you, ma'am.
If there is any questions, you can ask me. Okay.
Ma'am, share your Google Colab link.
Yes, I'll share that to your professor, Professor Hem Kumar P. Okay.
Okay, ma'am.
Okay.
Now it's time to propose the vote of thanks. Successful people build each other up, they motivate, inspire, and push each other. It's my tremendous honor to propose a vote of thanks in this session. On behalf of Puducherry Technological University, I extend a hearty thanks to our chief guest, Ms. Helsa Sharu Johnson, who spared her precious time to grace this occasion. Through this event, we had an opportunity to hear your fascinating thoughts and lecture and gain much knowledge on data analysis with Python, and this will surely encourage us in all our future endeavors. Last but not least, I thank the participants for your active participation throughout the consecutive days. Before we wrap up, I recommend all to kindly fill the feedback form shared in the chat box. Thank you all once again.
Thank you, ma'am. Thank you for giving the opportunity for presenting to your students. Hemkumar sir. Um, so I hope this session has been helpful for everyone. So Pairavi ma'am, can I leave this session? Is it
Yes,
okay?
ma'am. Yes, ma'am. Thank you, ma'am.
Okay. I'll be contacting Hemkumar sir for sharing the Google Colab sheets. Okay.
Okay, ma'am.
Okay. Thank you.
Thank you, ma'am.